Hi everyone. So good afternoon all. So good afternoon. Okay. So hi everyone. Good afternoon all. So first of all, let me know whether audio and video, everything clear here? Yes. So first of all, let me know whether audio and video, everything clear? Yes. Jishan Ahmad, is audio and video everything clear here? Yes. Okay. So I hope everything is clear here. I hope audio and video everything is clear. I hope so. Right? Okay. Okay. See here. So in the previous session, so just I am revising here whatever we have done in the previous session. Okay. So our subject is what here? Our subject is electromagnetics. Okay. Okay. So so in the previous session we have started with what here? We have started Coulomb's law. Yes or no? So we have started Coulomb's law in the previous session. So we have started Coulomb's law. So what I have explained here? What I have explained? So whenever you are having 2 point charges that are separated by a distance r, then the force between those 2 point charges is directly proportional to product of the charges and inversely proportional to square of the distance between them. Now if you observe, on LHS side the units are newtons, on RHS side the units are Coulomb square per meter square, Okay, so the units on LHS side is not same as what here? Is not same as the units on RHS side, right? Okay. Hello. Okay. So the units on LHS side is not same as what here? Units on RHS side. So now see here. So we have included, whenever you are putting equality, what you have to do? You have to include a proportionality constant. Let us say that proportionality constant is K. So F is equal to K into what? K into Q1 Q2 by R square. Now what must be the units of K here? What must be the units of K? So you have to choose the units of K such that the units on LHS side must become same as what? The units on RHS side. So already we know that for Q1 Q2 by R square, the units are nothing but Coulomb square per meter square. So the units of K, proportionality constant, must be Newton meter square per Coulomb square. Right? Okay. And also we have seen that the force between any 2 point charges, is not only depending upon what? Is not only depending upon the product of the charges and square of the distance between them. It is also depending upon what here? It is also depending upon the medium in which you are calculating the force. Right? Okay. So in the proportionality constant, K, we have included what here? We have included medium parameter, because the force between the charges is also depending upon the medium. Right? Okay. So F is equal to, in place of K, what we have written here? 1 by 4 pi epsilon, Q1 Q2 by R square, So this is nothing but what? This is nothing but proportionality constant K. So in proportionality constant K, we have included the medium parameter, that is epsilon. So we know that epsilon is equal to what? Epsilon is equal to epsilon naught into what? Epsilon naught into epsilon R. Right? So epsilon is called as what here? Epsilon is called as permittivity of any medium, and epsilon naught is called as permittivity of free space, and epsilon R is called as relative permittivity. So the units of epsilon is nothing but farad per meter. The units of epsilon naught is also farad per meter. Epsilon R doesn't have any units here. Yes or no? Okay. So therefore here you can write epsilon R is equal to what here? Epsilon by epsilon naught. Epsilon R is equal to epsilon by epsilon naught. So what do you mean by relative permittivity here? it is a measure of permittivity of any medium with respect to what? With respect to permittivity of free space. Now here you are measuring the permittivity of any medium with respect to what here? With respect to permittivity of free space. Permittivity of free space. Right. Okay. So for example, yesterday I have taken some examples like epsilon r is equal to, suppose if you take 5. So what do you mean by epsilon r is equal to 5? That means for this medium the permittivity is 5 times that of what? That of permittivity of free space. So for any medium we are measuring the permittivity with respect to what? With respect to permittivity of free space. Right. Okay. So since it is a relative measure, it is a relative measure of permittivity. We call it as what here? Relative permittivity. Right. Okay. So, and also we have seen that this epsilon r is going to represent just simply a number. It doesn't have any units. And what is its range here? Epsilon r is always greater than or equal to what? Epsilon r is always greater than or equal to 1. So for free space we have seen that epsilon r value must be equal to 1 for free space. For free space or air medium or vacuum. So for all this medium, we will simply consider epsilon r is equal to what? Epsilon r is equal to 1. So for any other medium, epsilon r will be what? Epsilon r will be greater than 1. So this is for any other medium. Okay, so that means what here? That means what? Whenever you try to find out the force between any 2 point charges, we will get 1 by 4 pi. Epsilon is nothing but epsilon naught into epsilon r into q1 q2 by r square. q1 q2 by r square. Right. Okay. So here, so that means what we can conclude here? What we can conclude? See, if you observe 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught into q1 q2 by r square is nothing but the force experienced, the force between 2 point charges in free space or not. Don't consider epsilon r here. Don't consider epsilon r. If I simply write 1 by 4 pi epsilon naught into q1 q2 by r square. So this is the force between 2 point charges in which medium? Air medium or free space or whatever it may be. So let us consider it is in air medium or something. So you can represent in air medium or free space or vacuum. All mean same here. So F air divided by what? Divided by epsilon r. So in this manner I can represent. Understood? So this is the force for any medium here, for any other medium. The force between the charges in any other medium is equal to what? Is equal to the force between the charges in air medium or free space or vacuum divided by what? Divided by epsilon r. So that means what we can say here? What we can say from this relation? The force between any 2 point charges is maximum. Is maximum in which medium here? In free space or air medium. Yes or no? In all the other medium, the force is going to be lesser when compared to what? When compared to free space. So these are the conclusions we have drawn here in the previous session. Okay. Okay. Yeah. Next, so in a flow, I have just said this epsilon r as a dielectric strength of the material. I have said it as dielectric strength of the material. No, here epsilon r. It is by mistake I have told like that. Okay. So epsilon r is also called as dielectric constant here. Dielectric constant. So please rectify this one here. Okay. So just in a flow, I have called it as simply dielectric strength. It is not dielectric strength. It is called as what? Dielectric constant of the material, or we can call it as relative permittivity. So we can call it as relative permittivity or dielectric constant of the material. Right. Okay. Okay. Yeah. So please correct this one here. Right. Okay. Next. So once we complete this one, so once we have completed this one, so that means we have seen how to determine the magnitude of force between any 2 point charges. Now we have seen how to determine the direction. Yes or no? We have seen how to determine magnitude as well as we have seen how to determine direction. So how to determine direction here? We have taken q1, q2 here and separated by some distance r here, right? So the force between these 2 point charges, how you have to write? First what I have told. So write down only magnitude. Magnitude must be always positive. That's what I have told. Yes or no? So write down k into q1, q2 by r square. So this must be always what? Always consider it as what? Consider it as positive. Yes or no? Now, if you want to determine force on 2 due to 1. So this is how you have to represent. Yes or no? This is the convention we are following. So always here you have to represent force on which charge, due to which charge. Yes or no? So here you have to write due to which charge, here you have to write force on which charge. Okay, so force on Q2 due to Q1 is equal to, this is the magnitude, and what I have told you, direction. See, we have taken two cases here. We have taken two cases. In first case, if Q1 and Q2 are of same polarity, if I consider Q1 and Q2 are of same polarity, so then in that case, so if Q1 and Q2 are of same polarity, in that case, in which direction it is going to experience the force here? Q2 is going to experience the force away from what? Away from Q1 or not? Because if both are of same polarity, the force between them is repulsive force. So it is going to experience the force. The force on 2 due to 1 is going to point in this direction. So you have to write the unit vector that is pointing in this direction. So that is A to 1 cap. So I have told you how to write the unit vector. So what you have to do? So here let us consider this point is x1 comma y1 comma z1, and this point is x2 comma y2 comma z2. So I have told here what you have to do. So you have to write increment in x as you move from this point to this point. What is the increment in x? Will give you x component, and increment in y will give you y component, and increment in z will give you z component, divided by what? Divided by its magnitude. Yes or no? Divided by its magnitude. So I have told here already this one. Yes or no? Okay. Okay. So if both are of opposite polarity, then what will happen here? So if Q1 and Q2 are of opposite polarity, separated by same distance, then what is the force on 2? What is the force on 2 due to Q1? Now here I am considering Q1 and Q2. This is case 2 here. So Q1 and Q2 are of what? Are of opposite polarity. Just I am revising here. Already we have seen all these things, right? Okay. So Q1 and Q2 are of opposite polarity. So if Q1 and Q2 are of opposite polarity, then in which direction this Q2 is going to experience the force? It is going to experience the force towards what? Towards Q1. Yes or no? Okay. So the force on Q2 due to Q1 is going to point in this direction. So you have to represent the unit vector. In this direction, right? Okay. So here I have told you how to represent the force in this case. So the magnitude will remain same here. Right? Now here the direction is what here? So here let us consider this point is x1 comma y1 comma z1, here x2 comma y2 comma z2. Now the vector is pointing from this point to this point. Understood? Okay. So as you move from this point to this point, what is the increment in x? That is going to give you x component. Increment in y, that is going to give you y component. Increment in z, that is going to give you z component. So write down that vector here. So write down the vector here, and divided by what? Divided by the magnitude of the vector, right? Okay. So what is the vector? You have to write the vector that is pointing from x2 comma y2 comma z2 to x1 comma y1 comma z1. So you have to write increment in x plus increment in y plus increment in z. Okay, so divided by its magnitude, that is going to give you the unit vector. And I have told that always you have to write the magnitude as what here? Positive. This unit vector will take care of what? Unit vector will take care of direction. Unit vector will take care of what? Will take care of the polarity of the charge. Yes or no? So if you change the polarity, the direction of unit vector will also going to change. Understood? So we always take the effect of polarity. The effect of polarity will be taken care by what? Will be taken care by unit vector. So that's why whenever you are writing magnitude, always write it as positive irrespective of the polarity of charge carriers. Okay. So these are the things we have seen in the previous session. Okay. So Parameshwar, good afternoon. Good afternoon, Parameshwar. Good afternoon. Okay. So these are the things we have seen here. Next, finally, we have seen that whenever you are having more than 2 point charges, you have to apply what? You have to apply superposition principle. Yes or no? So if you are having Q1, Q2 and Q3, and if you are having Q4, if you want to determine the force on Q4 due to Q1, Q2 and Q3. What you have to do? You have to determine the force on Q4 due to what? Due to 1, and you have to determine the force on Q4 due to 2, and you have to determine the force on Q4 due to what? Due to 3, right? Okay, so here I am assuming Q1, Q2, Q3, Q4 all are of same polarity. Understood? Now if you want the net force on Q4, so if you want to determine the net force on Q4, so F4 net is equal to what? Is equal to force on 4 due to 1 plus force on 4 due to 2 plus force on 4 due to 3. So if you add up all these, you are going to get what? The net force experienced by Q4 due to all the other 3 charges. Yes or no? So this is called as what here? This is called as superposition principle. Superposition principle. Right? Okay. So based on this superposition principle, so I have solved one problem and I have given another problem as homework. Understood? Okay. So and also I have told how to solve that problem also. So I hope you have done that problem here. Okay. Okay. So now today we will try to solve some more problems here. Today we will try to solve some more problems. Okay. Okay. Now see here. So I hope you are clear how to determine the force between any 2 point charges. That means how to write the magnitude and how to write the direction. So these 2 things, I hope it is crystal clear and you have understood clearly. I hope so. Right? Okay. So if you understand these things clearly, then we can solve some more problems here. Some more problems. So we try to solve this problem here. We try to solve this problem. See here. So here what they have given here, what they have given, see here. So they have given that 4 identical point charges, 4 identical point charges, each of value q. They have given 4 identical point charges, each of value q, are located at the corners of a square. Are located at the corners of a square of side A, of side A. What must be the charge capital Q? What must be the charge capital Q? What must be the charge capital Q that has to be placed at the center of the square so that the system stays in equilibrium. So I am reading once again here problem. 4 identical point charges, each of value q, are located at the corners of a square of side A. What must be the charge capital Q that has to be placed at the center of square so that the system stays in equilibrium? Okay. So here what they have given is, they have given this diagram here. So here they are saying that 4 identical point charges, 4 identical point charges are placed at the corners of a square. Okay, so these are the 4 identical point charges that are placed at the corners of a square. Now they are asking what must be the charge capital Q. Sorry. Okay, so what must be charge Q that has to be placed at the center of a square? What must be the charge capital Q that has to be placed at the center of a square such that the system stays in equilibrium? So what do you mean by the system stays in equilibrium here? What do you mean by this statement, system stays in equilibrium? What do you mean by system? So whatever the setup they have given here, this setup, we can consider it as what? We can consider it as system. Yes or no? Okay. And they are saying that this system must stay in what here? Stay in equilibrium. So equilibrium means what here? Equilibrium means the net force on each and every charge. Net force on each and every charge. Net force on each and every charge must be what? Must be 0. then we can say the system is staying in equilibrium. So system means this whole setup we can call it as system. Okay, so this system must stay in equilibrium means in this system whatever the charge carriers that are present, the net force on all those charge carriers must be what? Must be equal to 0. Must be equal to 0. Then we can say the system stays in equilibrium. Okay, so they are asking what must be the charge capital Q that has to be placed exactly at the center such that the net force on all the charges, will go to what? Will go to 0. Understood? Has to become 0. Understood? So you have to determine this capital Q value. Now see here. Now see here. Now see here. Okay. Now just we will name all these charges here. We will name all these charges. We know all are identical charges. Whatever the charges that are placed at the corners of a square, all are identical charges. Yes or no? So just name them here. Let us assume this is Q1, and let us assume this is Q2, and let us assume this is Q3, and let us assume this is Q4, and let us assume this is Q5. Okay, so that means we have considered here Q1 is equal to what? Same as Q2 is same as what? Q3 is same as what? Q4, that is equal to Q. Right, and Q5 is equal to what? Is equal to Q. Understood? Okay. Okay. Now, now if you observe here, so what is the net force experienced by this Q5 here? What is the net force experienced by this Q5? See, exactly, this is exactly at the center here. This is exactly at the center, right? Okay. Now, if you observe here, the force on Q5, due to Q2 is going to point in which direction here? It is going to point in this direction. Yes or no? The force on Q5 due to Q2 is going to point in this direction. So this is force on 5 due to 2. Right. Next. The force on 5 due to Q4, the force on 5 due to Q4 is going to point in this direction. So this is force on 5 due to 4. Here I am assuming all the charge carriers are having the same polarity. This is the assumption I am making here. Okay, so here due to Q2 the force on Q5 is pointing in this direction. Due to Q4 the force on Q5 is pointing in this direction. Now if you observe here, the distance between Q2 and Q5 and the distance between Q5 and Q4 both are same, and hence what will happen here? The magnitude of Fi2 will be same as what here? The magnitude of Fi4. Okay, see Q2 value is nothing but what? Q, and Q4 value is also nothing but what? Q, and the distance from here to here, is same. That means the magnitude of Fi2 will become same as what here? Magnitude of Fi4. And if you observe, these two forces are acting exactly opposite to one another. So if the magnitudes are same and if they are acting exactly opposite to one another, then what happens to the net force at this location due to Q2 and Q4? It will become 0. Yes or no? So due to Q2 and Q4, the net force on Q5 at this location will become equal to 0. Similarly, you can do the analysis with respect to what? Q3 and Q1. So due to Q3, the force on Q5 is going to point in this direction. So this is force on 5 due to 3. Similarly, due to Q1, the force on Q5 due to Q1 is going to point in this direction. So this is force on 5 due to 1. If you observe Fi3 and Fi1, so the magnitude of Fi3 will be same as what here? The magnitude of Fi1. Why here? Because Q3 value is what? Q. Q1 value is what? Q. The distance from Q5 to Q1 and the distance from Q3 to Q5, everything is same. Yes or no? So that's why the magnitude of Fi3 will become same as magnitude of Fi1. And if you observe, these two forces are also acting exactly opposite to one another, and hence the net force exactly at this center will become equal to what? Will become equal to 0. Yes or no here? Now that means irrespective of the charge here, irrespective of the charge that you have placed at the center, irrespective of the charge that you are placing at the center, the net force exactly at this center will become equal to what? Will become equal to 0. Understood? So irrespective of the magnitude of charge and irrespective of polarity of this charge. Okay, so the force, the net force exactly at the center of square loop will always become equal to what? Will always become equal to 0. So whatever may be the charge you place exactly at the center, the net force that is going to experience by that charge will be equal to what? Will be equal to 0. Understood? Okay, so I hope this point is crystal clear here. I hope this point is crystal clear. Understood here this one? Yes or no? So finally, irrespective of the charge that is placed at the center, whatever may be the charge that you place exactly at the center, that charge is going to experience what? That charge is going to experience net force equal to 0. Net force on that charge will be equal to 0, irrespective of its magnitude and polarity. So is this point clear here? Yes? Tell me here. If it is clear, next we will move on further here. Is it clear? Yes? Parmeshwar? Yes sir. Okay, fine. See, please do some interaction here whenever, that's why we are conducting live classes. Yes or no? So live class is for, we have to interact with one another. So then only we will understand whether you are able to getting the concepts clearly or not. Okay, so if you are having any doubts, you can ask in chat box. If you want me to repeat anything, I can repeat. Okay, so like that you have to interact with one another here. So that is the purpose of live classes. Paras moon, yes sir. Okay. Okay. So one thing we have confirmed that whatever may be the charge that you are going to place at the center, it is going to experience a net force is equal to 0. Fine. Okay, so one task is done here. One task is done. Okay, next see here. Okay. Okay. So here you are having Q, here you are having Q, here Q, here Q. So we have named it as Q1, Q2, Q3, Q4 and exactly at the center you are having what? You are having Q5, right? Okay, so I have told that Q1 is equal to Q2 is equal to Q3 is equal to Q4 is equal to Q, Q5 is equal to capital Q, right? Okay, fine. See here. Now if you observe here, Q1 here, if you observe Q1, okay, if you observe Q1, see, however this Q1 is placed with respect to these 4 charges here. However, this Q1 is placed with respect to these 4 charges. See, the distance here to here is A. Yes or no? From here to here is also A. The distance from here to here A. The distance from here to here A. Okay. Now, see here. However, this charge Q1 is placed with respect to these 4 charges. With respect to these 4 charges, in the same manner, Q2 is also placed. Q2 is also placed with respect to these 4 charges. Yes or no? However, Q1 is placed with respect to other 4 charges. In the same manner, Q2 is also placed. In the same manner, Q2 is also placed with respect to other 4 charges. In the same manner, Q3 is also placed with respect to other 4 charges. In the same manner, Q4 is also placed with respect to other 4 charges. So understand this point here. However, this Q1 is placed with respect to these 4 charges. In the same manner, Q2 is also placed with respect to these 4 charges. In the same manner, Q3 is also placed with respect to these 4 charges. In the same manner, Q4 is also placed with respect to these 4 charges. So, what we can conclude here, if all are placed in the same manner, Q1, Q2, Q3, Q4, all are placed in the same manner means whatever the magnitude of force Q1 is going to experience, Q2 is also going to experience the same magnitude of force, Q3 is also going to experience the same magnitude of force, Q4 is also going to experience the same magnitude of force. Yes or no? Yeah? Yes or no? Why means however this Q1 is placed with respect to 4 charges, in the same manner Q2 is also placed, in the same manner Q3 is also placed, in the same manner Q4 is also placed, and hence whatever the magnitude of force experienced by Q1, Q2 is also going to experience the same magnitude of force, and Q3 is also going to experience the same magnitude of force, and Q4 is also going to experience the same magnitude of force. Okay, so I hope it is crystal clear here. I hope it is crystal clear, right? Yes or no? Yeah? Okay, so that means here what is the conclusion here is, if you try to if you make the net force acting on Q1, if you make the net force acting on Q1 is equal to 0, then Q2 on Q2 will also it will become equal to 0. Q3 also it is going to experience the same force. Q4 is also going to experience the same force. And we have already seen that irrespective of the magnitude and polarity of the charge that is placed at the center, always the net force acting on this charge will be equal to 0. Then all the charges on all the charges the net force will be 0. Then we can say the system is staying in equilibrium. Right? Okay, so we try to determine the net force acting on Q1 here. You can take any other charge here, you can take any other charge, that's your wish. Understood? You can take any other charge and follow the same procedure. Okay, so I am considering here Q1 here. I am considering here Q1. Okay. So here I am considering this axis I am considering as x direction, positive x, and this is positive y direction. This is positive x direction I am considering, and this is I am considering positive y direction here. Okay, this is positive x, positive y. Now now if you observe Q2, so what is the direction of force? What is the direction of force on Q1? On Q1 due to what? Due to Q2. That means you have to determine the force on 1 due to 2. So in which direction this Q1 is going to experience force? Due to Q2. So all are of what? All are of same polarity. Yes or no? So Q1 is going to experience the force in this direction. Yes or no? So this is force on 1 due to 2. Force on 1 due to 2. Right. Next, if you observe due to Q4 here, due to Q4, in which direction Q1 is going to experience the force? It is going to experience the force in positive y direction or not? Always the force must be what? The force must be always along the line joining these 2 point charges. So due to Q4, the force on Q1 is going to be in this direction. Yes or no? So this is force on 1 due to what? Due to 4. Force on 1 due to 4. Right. Next. Due to Q3 here, due to Q3. So due to Q3, in which direction it is going to experience the force? Forget about all other charges here. Consider Q3 and Q1. Understood? Okay. So now in which direction it is going to experience the force? So always the direction of force must be always along what? Along the line joining the 2 point charges, right? Right. Okay. So this is force on what? Force on 1 due to what? Due to 3. Force on 1 due to 3. Next, what is left out here? Q5 is left out. Yes or no? Okay. So here you are having Q5. Q5. Okay, so now due to Q5, in which direction it is going to experience the force here? Due to Q5, in which direction it is going to experience the force? So due to Q5, the force on Q1 due to Q5. So it is going to point in the same direction. Yes or no? Always the force must be along the line joining the 2 point charges. So that means it will be along what? It will be along F13 only. Yes or no? So let us consider. This is what here? The force on 1 due to 5. The force on 1 due to 5. This is force on 1 due to 3. This is force on 1 due to 4. This is force on 1 due to 2. Right. Okay. So we have represented all the forces here. We have represented all the forces that are acting on what here? That are acting on Q1. So you have to determine the net force, and you have to equate that net force equal to what? 0. So if it becomes equal to 0, then by equating it equal to 0, you can determine this q phi value. Understood? Okay, so if the magnitude of force here becoming 0 means all the other charges is also going to experience the same magnitude of force. So it is as simple as that here. Now see here, now what is this angle here? What is this angle? Tell me. See, the distance from here to here is a, the distance from here to here is also a. Yes or no? The distance from here to here is also a. So that means what is this angle? This angle theta is equal to what? Theta is equal to 45 degrees. So if the angle between this line and this line is 45 degrees means what is the angle between this line and this line here? I am extending the same line here and this line is parallel to this one. So this angle is also equal to what? This angle is also equal to what? This angle is also equal to 45 degrees. Right? Okay. So now we are ready to determine, to make the net force equal to 0. Now see here. Okay, so here I am writing the net force here, the net force. So net force on what? Net force on 1. Net force on 1 is equal to, so what you are having here, F12 is pointing in x direction. Yes or no? F12 is pointing in x direction. So I am writing F12. It is pointing in which direction here? X cap direction. Next, F14 is pointing in ay cap direction. F14 is pointing in ay cap direction. Plus F13 here. F13 is neither along x nor along y. So you can resolve F13 into two components. One is along x direction, another one is along what? Y direction. So what is its component along x direction here? That is nothing but what? F13 cos 45. Yes or no? So if you draw the normal, onto x direction, so the distance from here to here is nothing but what? Is nothing but F13 cos 45 degrees. F13 cos 45 degrees. It is pointing in positive x direction. Now similarly, if you drop a normal from F13 onto y direction, okay, so the distance from here to here is nothing but what? So you can consider like this here, okay. So F13, this will become F13 sin 45. F13 sin 45. It is pointing in ay cap direction. Understood? So this F13 is having a component along y direction, that is F13 sin 45. It is having a component along x direction, that is F13 cos 45. Similarly, if you observe F15 here, it is having the component, it is going to have the component along x direction, and also it is going to have the component along what? Along y direction. So what is the component along x direction here? That is nothing but F15 cos 45. Yes or no? F15 cos 45 ax cap. And what is y component? What is y component? Y component is F15 sin 45. F15 sin 45 ay cap. Okay. So now write down here. So what we got? So F13 cos 45, F13 cos 45 is in ax cap direction, plus F13 sin 45 is in ay cap direction, plus similarly F15 cos 45 degrees, it is in ax cap direction, plus F15 sin 45 degrees ay cap. Right? Okay. Now if you observe here, so F12 ax cap, right? Next F13 cos 45, and then F15 cos 45. So all these are nothing but what? All these are nothing but x components. Yes or no? X components. Right? Okay. Next, if you observe F14 ay cap, and then F13 sin 45 ay cap, and F15 sin 45 ay cap. All these are nothing but what here? Y components. All these are nothing but y components. So therefore I can write here the net force on 1 here. The net force on 1 is equal to I can write summation of what? Summation of x components. Yes or no? It is the summation of x components plus what here? Summation of y components. Summation of x components plus summation of y components. So the net force must be equal to what? The net force must be equal to 0. The net force must be equal to 0. So what is the condition for net force to become equal to 0 here? Here this is the summation of what? Summation of all the x components. It is the summation of all the x components and it is the summation of all y components. So for the net force to become equal to 0, what must be the condition? What must be the condition? The summation of all x components must go to what? Must go to 0. Sorry here. So the summation of all the y components must also go to what? Must also go to 0. So then only this net force, will become equal to what? Will become equal to 0. Now take now take the summation of all the x components and try to equate it equal to 0. Or you can take summation of all the y components and try to equate it equal to 0. So now here we are considering the summation of all x components here. So what are the x components you are having? F12 ax cap, F13 cos 45 and then F15 cos 45. Yes or no? So therefore the net force on 1 is equal to F12 ax cap plus F13 cos 45 ax cap plus what? Plus F15 cos 45. Yes or no here? Okay, so this is the summation of what? Sorry, this is not F1 net here. So this is summation of what? Summation of all x components. Summation of all x components. Okay, so this must be equal to what? This must be equal to 0. This must be equal to 0. Now one more thing you can see, one more thing you can observe here is the force on 1 due to 2 here, the force on 1 due to 2, F12 is equal to what here? F12 is equal to Q2 into Q1. So that is K into Q2 into Q1 is nothing but Q square divided by what? Divided by A square. This is F12 value, right? Next, what is F13 here? What is F13? Tell me. So F13 here, F13 is equal to what here? F13, the force on 1 due to what? Due to 3. So the force on 1 due to 3 is nothing but what? K into Q3 into Q1, that is Q square divided by what? Divided by the square of the distance between these two. What is the distance from Q3 to Q1 here? What is the distance from Q3 to Q1? Tell me. Here this is A, this is A. So the distance from here to here will become what? Will become root 2A. Will become what here? Root 2A. So the distance from here to here is root 2A. So K Q square by root 2A whole square. So that is 2A square. 2A square. Okay. So this is so we have to determine what? We have to determine F13 cos 45. Yes or no? Okay. So this is F13. So F13 cos 45 is equal to, so this is F13 here, this is the magnitude of force, that is KQ square by 2A square, cos 45 value is 1 by root 2. Now similarly, what is F15 cos 45 here? What is F15 cos 45? Tell me. So F15 cos 45. So what is F15? F15 is the magnitude of force between what? Between Q5 and Q1. So what is the distance between Q5 and Q1 here? So this whole distance is root 2A. So the distance between Q5 and Q1 is root 2A by 2. So that means it will be 1 by root 2A. Yes or no? So the distance between Q5 and Q1 is 1 by root 2A. So F15 magnitude is nothing but what? Is nothing but K into Q square by 1 by root 2. 1 by root 2A whole square into cos 45, that is 1 by root 2. So these are the values of what? So these are the values of F12 F13 cos 45, F15 cos 45. So substitute all this here, substitute all this in this expression. So what you are going to get here? What you are going to get? Tell me. So so I am considering only the magnitude here. I am considering only magnitude. So what you are going to get? Tell me. So you are going to get k q square by a square plus what? Plus k q square by 2a square into 1 by root 2. Yes or no? I am considering only magnitude here. Plus f15 cos 45, that is k, it is not q square here, sorry, f15, the force on 1 due to q5. Yes or no? So that means here k into q into q5. Yes or no? Q into capital Q here, q into capital Q, q5 means capital Q. Yes or no? So k into q into capital Q here, right? So f15 is nothing but k into q into capital Q divided by what? Divided by 1 by root 2a whole square. So that means I can write it as 2k q, yes or no, 2k small q into capital Q by a square into 1 by root 2, 1 by root 2. So this is the magnitude of x component. So this must be equal to what? This must be equal to 0. So now here what you can take common here? What you can take common? So here from all the terms you can take k q by a square. You can take k q by a square common. So k q by a square. So k q by a square. Yes or no? So you can take all this common here. So then what is left out? What is left out? Here q, and here you are going to have q by 2 root 2 plus here root 2, and here you will get root 2. Yes or no? So I can write it as root 2 capital Q. So this must be equal to 0. This must be equal to 0. So from here I can write Q is equal to what here? Q is equal to minus of Q into 1 plus 1 by 2 root 2 divided by what? Divided by root 2. Divided by root 2. Yes or no? So therefore Q is equal to minus Q into, here I can write it as 2 root 2 plus 1 divided by 2 root 2. Okay, so 2 root 2, here you are having root 2. So finally I can write, you just simplify this one here. So finally I can write minus Q by 4. Yes or no? Finally I can write minus Q by 4 into what? Into 2 root 2 plus 1. 2 root 2 plus 1. So this is the value of what? This is the value of capital Q that has to be placed. Exactly at the center of square. So that the system will stays in what here? So that the system will stays in equilibrium. Okay. Now they may give any value here. They may give, if suppose they have given Q is equal to 1 microcoulomb, just substitute this one here. Just substitute in this expression, so that you will get capital Q value. Understood? So finally what we got here? Finally what we got? Q is equal to minus Q by 4 into 2 root 2 plus 1. So that means here so here in this problem, so here Q5, yes or no? So this Q5 is equal to what? Is equal to minus Q by 4 into 2 root 2 plus 1. So 2 root 2 plus 1. So that is the charge that you have to place exactly at the center. Understood? So that the net force on all the charges will become equal to what? Will become equal to 0. Yes or no? See here, I have made x component, the summation of all the x components equal to 0, then I got Q value. If you want, you can make the summation of all components equal to, summation of all y components equal to 0, then also you are going to get what? You are going to get the same Q value. So whatever you can take, finally you are going to get the same answer, right? So if you place this charge exactly at the center, then the system is going to stay in what here? Then the system is going to stay in equilibrium, right? Okay. So understood here this problem? Yes or no here? Let me know, is it clear? Yes, is this problem clear here? I am just waiting for your reply here. Is this problem clear? Yes, Paras Moon, yes sir. Okay, come on here, give some replies here. Only one person has given the reply. What about the others? Have you understood this one? Yes. Okay. So here we got Q is equal to what? Is equal to minus Q by 4 into 2 root 2 plus 1. So that means the polarity of the charge that you have to place at the center is negative here, is negative, right? Okay. 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 So I hope this is clear here. I hope this is clear, right? Okay. Next here, if suppose if suppose I give the same type of problem here, if I give the same type of problem by considering what? By considering equilateral triangle, So that means here I am placing the 3 point charges here, Q and Q and Q here, right? So all are identical charges here. Okay, so all the 3 point charges all the 3 identical point charges are placed at the vertices of what? At the vertices of an equilateral triangle. Okay, so if you want you can write that. Okay, so all the three identical point charges are placed at the corners, at the vertices of an equilateral triangle. Okay, equilateral triangle, at the corners of a equilateral triangle. Then determine the value of capital Q, that has to be placed at the centroid of an equilateral triangle. So then determine the value of capital Q that has to be placed at the centroid of an equilateral triangle, so that the system stays in equilibrium. Okay, so 3 identical point charges, that is Q, 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 okay, are placed at what here? Are placed at the vertices of an equilateral triangle. So this is equilateral triangle here. So that means here this angle is 60 degrees, this angle is also 60, this angle is also 60. So the distance or the length of each side is A. This is the equilateral triangle. Now let us consider this as centroid. So this centroid I am naming it as O, right? So this is the centroid. Now at this centroid, what must be the value of Q? What must be the value of q that you have to place exactly at this centroid, exactly at this centroid, such that the system stays in equilibrium. The system stays in equilibrium, right? Okay. Okay. Narahari Yadav, sir, there is no lectures after 5th lecture. I mean, you are asking in a playlist here. Okay, okay. I will ask them to add further lectures here. Okay. So I haven't seen that. So it is there only for 5 lectures. Okay, okay. So I will add up other lectures also here. Don't worry. Right. Okay. Okay. So it is almost here, this problem is almost similar to the previous problem or not? Yes or no here? It is almost similar to the previous problem, right? So what we have done, so instead of taking a square, here I have considered an equilateral triangle. So at the vertices of an equilateral triangle, you have placed 3 identical point charges. Now exactly at the centroid, what must be the charge capital Q that has to be placed so that this total system stays in what? Stays in equilibrium. So that means what here? That means the net force on each and every charge must be equal to what? The net force on each and every charge must be equal to 0. Now if you observe what is the force on this charge Q here? What is the force on this charge Q? What is the net force experienced by this charge Q, which is placed exactly at the centroid? See here. So let us name it as Q1, Q2, Q3. And let us name it as Q4 here. Here, whatever the charge that is present at the centroid, so name it as Q4. Right? Okay. Now if you observe the force on Q4 due to Q1. So let us assume all are of same polarity. So the force on Q4 due to Q1 is going to point in this direction. Yes or no? It is going to point in this direction. Right? So it is going to point in this direction. Okay, it is pointing in this direction. The force on 4 due to 1, it is pointing in this direction. Right? Okay. Next, the force on 4 due to 2, it is going to point in this direction. The force on 4 due to 2. So this is force on 4 due to 2. Next, similarly, the force on 4 due to 3 is going to point in this direction. So the force on 4 due to what? Due to 3. Right. So now what is the net force acting on Q4 here? What is the net force acting on Q4? Tell me here. Now see here, what is this angle here? What is this angle? So this total angle is 60 degrees. So this angle will be what? This angle will be, so this total angle is 60 degrees. So this angle will be 30 degrees. Yes or no? So this angle is also 30 degrees. Right? Okay. Okay, yeah. So now if you determine F42 here, F42 is pointing in this direction. Now let us consider this is X direction and let us consider this is Y direction. Let us consider this is X and this is Y direction here. Now if you consider F42, it is neither along X nor along Y. So you can resolve this into 2 components. So let us say you can resolve it into 2 components. One is along what? One is along X direction. Yes or no? So this is F42. So what is this angle? This angle is also 30 degrees. So F42 cos 30 degrees. Yes or no? It is pointing in this direction. So what is its Y component here? Its Y component is going to point in this direction. So this is what? This is F42 sine 30 degrees. This one. Right? Now similarly, if you observe, the force on 4 due to 3 is pointing in this direction. Yes or no? It is pointing in this direction. Right? Okay. Now Now if I split this F43 into two components, one is what? One is along x direction, yes or no? So this angle is also nothing but what? This angle is also nothing but 30 degrees. This angle is also nothing but 30. So this is 30, this is also 30. So this will become what? This will become F43 cos 30, F43 cos 30 degrees. And what is its vertical component here? Vertical component will become what? Will become F43 sin 30, yes or no? So I am writing here, I am writing, okay. So this one here, okay. So this is y component, that is F43 sin 30. Sin 30 is in ay cap direction, right? Okay. See, charge Q4 is present like this here. So here you are having Q2, here you are having Q3, and here you are having Q1, right? So due to Q2, it is pointing in this direction. This is force on 4 due to 1, due to force on 4 due to 2, and due to Q3, it is going to point in this direction. So this is force on 4 due to 3, and due to Q1, it is going to point in this direction. So this is force on 4 due to 1. Now if you observe, we have resolved this into two components. So here we got this as what here? F42 cos 30 degrees, yes or no? This angle is what? 30 degrees. This angle is 30 degrees, right? So this is the equilateral triangle, okay. Okay, next its component, this one will be what here? This one will be F42 F. So this one will be F42 sin 30 degrees, sin 30 degrees. Next, similarly this F43 can be resolved into two components. One is what here? One is along this direction, that is F43 cos 30 degrees. So this is angle is also what? 30 degrees. So this angle is also 30 degrees, right? So its vertical component, so its component will be what? Will be F43 sin what? Sin 30 degrees, sin 30 degrees, right? And this is F14, this is F14 is acting in this direction. Now if you observe here, this this F42 cos 30 is acting in this direction, and F43 cos 30 is acting exactly in opposite direction. And if you want, you can determine the magnitude of F42 will be same as what here? The magnitude of F43. The magnitude of okay, so the magnitude of F42 will be equal to what? The magnitude of F43. Why are the distance between Q2 and Q4 and the distance between Q3 and Q4 both are what? Both are same. Yes or no? Okay, so and also here Q2 is equal to Q and Q4 is equal to Q, and here Q3 is equal to small q, Q4 is equal to capital Q. So that's why you are going to get what? The force on Q4 due to Q2 and the force on Q4 due to Q3 will become what? Will become same. Will become same. So that is the magnitude of force on 2 due to 4 and the magnitude of force on 4 due to 3. So due to this one and due to this one, the magnitude of forces will become same. Understood? Okay. So if F42, if F43, this is the magnitude, yes or no? Here F42 is the magnitude. So if F43 and F42 both are same, okay, here you are having F43 cos 30, here you are having F42 cos 30. So these two will also become same, and these two are acting exactly what? Exactly opposite to one another. So these components will get what here? Will get cancelled. See, F42 cos 30 is acting in this direction and F43 cos 30 is acting in this direction. Both magnitudes are also same and they are acting exactly opposite to one another. So you will get what here? You will get net force along x direction will become equal to what? Will become equal to 0. Next, what are the forces that is left out here? Here the y component of F43, that is what here? F43 sin 30 degrees, yes or no? and F4 to sine 30 degrees. Both are pointing in the same direction, that is in plus y direction. Yes or no? So F4 3 sine 30 plus what? F4 to sine 30. F4 to sine 30. So both are acting in what? Both are acting in same direction, that is in ay cap direction. Right. Now magnitude of F42 and F43 both are same. Yes or no? So that means this F43 and F42 both are same. Yes or no? Next, here you are having sine 30, here also you are having sine 30. So you can write it as simply 2 F43. Yes or no? 2 times of F43 into sine 30. Sine 30 is 1 by 2. So this force is acting in which direction here? Ay cap direction. This is the force that is acting in ay cap direction. Now what is the force that is acting in negative y direction here? Negative y direction, that is F41. So this is the force between Q1 and Q4. Q1 and Q4. So what is the force between Q1 and Q4 here? Tell me. What is the force between Q1 and Q4? That is what? That is F41. Right. That is F41. So this is equal to what? F41. This is equal to Q1 into Q4. So that is equal to Q1 into Q4. That is Q1 value is Q. Q4 value is capital Q. Right. So K into Q divided by what? Divided by square of the distance between these two. See, what is the distance? What is the distance between Q1 and Q4 here? What is the distance between Q1 and Q4? Tell me. What is the distance between Q1 and Q4? Tell me here. See, if you take a equilateral triangle here, if you consider an equilateral triangle, we know that the centroid will always divide this perpendicular bisector. This is centroid here, or I will draw separately here. See, if you consider an equilateral triangle, we know that the centroid O is going to divide this perpendicular bisector here. This is the perpendicular bisector. So this centroid O is going to divide this perpendicular bisector in which ratio here? 2:1 ratio. 2:1 ratio. Yes or no? Okay. So I hope you know this one here. So let us say this is A, this is B. So AO is to what? AO is to OB is equal to what? Is equal to 2:1. 2:1. So let us say the total distance from here to here. Let us say the total distance from here to here is is D here. Let us say the total distance from here to here is D. Okay. So then AO is equal to what here? AO is equal to what? AO is equal to 2 by 3 times of what? 3 times of D, and OB is equal to what? 1 by 3 times of D. So now what is this D value here? What is this D value? We know that this angle is what? This angle is 60 degrees, and the distance from here to here is A by 2. Yes or no? And the distance from here to here is A. Right. So D is nothing but what? D is nothing but this one. Yes or no? So D is equal to what? D is equal to square root of A square minus what? A square by 4. So if you do this, you are going to get root 3 A by 2. Root 3 A by 2. So this total distance here, the length of this perpendicular bisector is nothing but root 3 A by 2. Root 3 A by 2. Yes or no? So now what is AO value? What is AO? AO is nothing but the distance between A and O point. A and O point. Okay. So AO is equal to what here? AO is equal to 2 by 3 times of what? 2 by 3 times of root 3 by 2 into A. So 2 will get cancelled. So you will get what? You will get 1 by root 3 A. 1 by root 3 A. So this is the distance between what? This is the distance between this point and this point. Yes or no? So that means it is the distance between what here? It is the distance between Q1 and Q4. Yes or no? The distance between Q1 and Q4. Yes or no? From here to here, that is AO. So let us say this is A and this point is O. This point is O. So the distance from A to O is nothing but what here? Is nothing but what? 1 by root 3 A. 1 by root 3 A. Okay. Now here substitute that one here. K Q into capital Q. So divided by what? Divided by 1 by root 3 A whole square. It is pointing in which direction? It is pointing in which direction here? So 1 by root 3 A. Yes. Okay. So it is pointing in negative y direction. It is pointing in negative y direction. So therefore F41 here, F41 is equal to 3 into K Q Q divided by what? Divided by A square. It is in minus AY cap direction. It is in minus AY cap direction. Right? Okay. Next, what is the value of this one here? Here 2 will get cancelled. So what is the value of F43? F43, that is the force on 4 due to 3. Yes or no? So that is the force on Q4 due to Q3. Right? So what you will get here? What you will get? So the distance from here to here, the distance from here to here is also what? Is also 1 by root 3 AR. The distance from here to here is also 1 by root 3 A. Right? Okay. So F43 is equal to what? Is equal to Q into capital Q divided by 1 by root 3 A whole square. Here you will get K. So it is pointing in which direction here? So 2 into F43 1 by 2 into AY cap. So into AY cap. Understood? Okay. So sorry. So this total value here, we got it as what here? So this total value we got it as K into Q into capital Q by 1 by root 3 A whole square, that is 3 into K Q capital Q by A square into AY cap. Right? Okay. So this is the this total force here, this total force is acting in positive y direction. Yes or no? So the net force that is acting in positive y direction is 3K Q capital Q by A square, and the total force that is acting in downward direction is what here? 3K Q capital Q by A square in negative y direction. Yes or no? So this force is acting in positive y direction and this force is acting in negative y direction. So if you add up these two, what you are going to get? You are going to get 0 or not? Yes or no? So that means whatever the charge that you are going to place at the centroid, the net force it is going to experience is always equal to what? Is always equal to 0, irrespective of its magnitude and polarity. Yes or no? Okay. See here you have added F43 sin 30 and F42 sin 30. Yes or no? So the resultant y component is this one. Next, we have determined F41. So this is the value of F41. Yes or no? So you are adding this component that is pointing in negative y direction and the component that is pointing in positive y direction, that is F43 sin 30 and F42 sin 30. Here F43 cos 30, F42 cos 30 will get cancelled here. So remaining is in positive y direction here. Here F41 is pointing in negative y direction. We have seen that the summation of F43 sin 30 and F42 sin 30, that is pointing in positive y direction, is what here? What we got? We got the summation of these two is nothing but what? Is nothing but 3K small q into capital Q by A square. It is pointing in positive y direction. Yes or no? And for F41 we got it as what here? 3K Q capital Q divided by what? A square. It is pointing in negative y direction. So so what is the net force acting on Q4? So if you add up these two, you are going to get what? These two will get cancelled. So the net force on Q4 will be equal to 0. So that means whatever the charge here, whatever the charge that you are going to place at the centroid, always the net force experienced by that charge will be equal to what? Will be always equal to 0. Understood? Okay. Okay, yeah. So is this point clear here? Yes. See, you also do along with me here. You also try to solve the problem along with me. So then you can easily understand. Okay. So I hope it is clear here. Here you are having Q. So here you have placed capital Q, right? So due to this one, the force is acting in this direction. Due to this one, the force is acting in this direction. Okay, so due to this one, it is acting in this direction. Due to this one, it is acting in this direction. We have resolved this into two components, yes or no? So these two components will get cancelled, and the components that are in positive y direction will get added up. So due to this charge Q, the force on this Q4 is acting in this direction. We have determined this this addition of y components, and also you have determined this component, yes or no? So these two will also get what? These two will also get cancelled, and hence the net force on Q4 will be equal to what? Will be equal to 0. So exactly at the centroid, because of these 3 point charges, the net force exactly at the centroid will always become equal to 0, irrespective of what? Irrespective of the magnitude of charge and polarity of charge. Understood? Okay, so I hope it is clear here. I hope it is clear. Okay, next what you have to do here? Next what you have to do? You have to determine, you have to determine what value of capital Q, that has to be placed at the exactly at the center, so that the net force on all the other 3 point charges will also go, must also go to what? Must also go to 0. So let us say this is Q1, Q2, Q3. So here this is Q4, right? Okay. So let us say this is A. So this point O. So this point we have considered as B. Always it this centroid will divide this AB into 2:1 ratio. So AO is to OB is equal to what? Is equal to 2:1, right? Okay. So similarly, you can draw the perpendicular bisector like this here. You can draw perpendicular bisector like this. So like this. So this centroid is going to divide this perpendicular bisector in the ratio 2:1. So the same manner. Here also you can draw like this. Understood? Okay. So in any manner you can consider, no problem, right? So I hope this is clear here. Next, see here. However, this Q1 is placed with respect to Q2, Q3 and Q4. However, this Q1 is placed with respect to these 3 charges. In the same manner, Q2 is also placed with respect to other 3 charges. In the same manner, Q3 is also placed with respect to other 3 charges. Yes or no? So that means if the net force, if you try to determine the magnitude of net force on any one charge, then other charge is also going to experience the same magnitude of force, and this charge is also going to experience the same magnitude of force. Why means, however, this Q1 is placed with respect to these 3 charges, in the same manner Q2 is also placed with respect to these 3 charges. In the same manner Q3 is also placed with respect to these 3 charges, and hence whatever the magnitude of force Q1 is going to experience, Q2 is also going to experience the same magnitude of force, and Q3 is also going to experience the same magnitude of force. Understood? Okay. Okay, yeah. So first try to determine the magnitude of force on Q1 here, magnitude of force on Q1, and then equate that magnitude of force equal to 0. So if you equate it equal to 0, then you can determine the value of what? You can determine the value of Q4, right? Okay. Okay, yeah. So now, sorry, same manner here, same manner. Whatever the procedure we have followed for square, the same one. Okay. Now if you observe here, so we have considered this as x direction and this as positive y direction. Now Q2. So due to Q2, the force on Q1, is going to experience the force in this direction. So this is force on 1 due to 2. So due to Q3, it is going to experience the force in this direction. So this is force on 1 due to what? Due to 3. Right. Next, due to Q4, so I will use, okay, so due to Q4, it is going to experience the force. Always the force must be what? Along the line joining the 2 charges. Yes or no? So let us say this is what? This is force on 1 due to what? Due to 4. So these are the forces that are acting on Q1. Now if you observe here, the same procedure here, see here, F12 is neither along X nor along Y. So you can resolve this into what? You can resolve this into 2 components. Yes or no? Okay. Similarly, this F13 is neither along x nor along y, so you can resolve this into two components. So one is along x and another one is along y. Right. Now what is this angle here? We know that this angle is 60 degrees. So this angle will also become what? Will also become 60 degrees. This angle will also become 60 degrees. Right. So this component will become what here? F12 cos 60. And this component will become what? F13 cos 60. Right. Because this angle is also what? 60 degrees. Why means this angle is also 60 degrees. Yes or no? Okay. Next, this component, the component of F12 along y direction is nothing but what? Is nothing but F12 sine 60. And the component of F13, along y direction is nothing but what? F13 sine 60. Right. Okay. So I have represented all these things here. Now, if you observe the magnitude of force on Q1 due to Q2 and the magnitude of force on Q1 due to Q3, both are going to be same or not? Because the distance from Q2 and Q1 and the distance from Q1 and Q3 is same, and Q2 value and Q1 value both are same. Here Q1 value, Q3 values are also same, and hence you can observe that the magnitude of F12 must be same as what here? The magnitude of F13. Yes or no? Magnitude of F13. Now that means here F13 is same as what here? F12. F13 is same as F12. And here you are having F13 cos 60 degrees. Here you are having F12 cos 60 degrees. That means F13 cos 60 degree value and F12 cos 60 degree value both must be same. Both are going to be same. And these two are acting exactly what? Exactly opposite to one another. Magnitude wise both are same and they are acting exactly opposite to one another. That means these x components will get cancelled with one another. Yes or no here? Now what is the net force acting on Q1 here? What is the net force acting on Q1? One is F13 sin 60, F12 sin 60 and then F14. So all these three components are acting in which direction? In positive y direction. Acting in positive y direction. So the net force on Q1 doesn't have any x component. It is having only y component. Yes or no? Okay. So here I am representing the net force on Q1 is equal to what here? Is equal to F12 sine 60 degrees. F12 sine 60 degrees. It is in AY cap direction plus F13 into sine 60 degrees. It is also in AY cap direction plus F14 it is also in AY cap direction. So this is the total net force acting on what here? Acting on Q1. Now here it is net force is having only y component. Yes or no? Okay. So for the net force to become, you have to make this net force is equal to what? Is equal to 0. Is equal to 0. So that means what is F12 here? What is F12? Tell me. So F12 here, F12 is equal to what? So the force between Q2 and Q1. So that is nothing but K into Q square divided by what? Divided by A square. Yes or no? Okay. This is F12. This is magnitude here, magnitude of F12. Next, if you want the magnitude of F13. So what is the magnitude of F13? So that is also nothing but what? The force on 1 due to 3. So that is K into Q square by A square. Next, what is the magnitude of F14? What is the magnitude of F14? F14 is equal to what? So the force between Q1 and Q4. Yes or no? So that is nothing but Q into capital Q, K into Q into capital Q divided by what? Divided by the distance between Q1 and Q4. We know the distance between Q1 and Q4. That is how much here? Between Q1 and Q4? 1 by root 3 A. So this is the distance. This is the distance between Q1 and Q4. So you can substitute that. So you are going to get 1 by root 3 A whole square. 1 by root 3 A whole square. Yes or no? Okay. So these are the magnitudes of F12, F13 and F14. So now therefore the net force on 1 is equal to what here? Is equal to, so K Q square by A square, that is F12. So sine 60 degrees. Sine 60 degrees is how much here? Root 3 by 2. right? So all are y components here, so I am adding up all, okay, plus f13 is k into q square by a square, k into q square by a square. Sin 60 is root 3 by 2, right? Plus f14 is, you will get 3k small q into capital Q by a square. So you have to make this magnitude here, okay? So here you will get ay cap, so you have to take magnitude. So take the magnitude, and this must be equal to what? This must be equal to 0. So if you equate this magnitude equal to 0, what you are going to get? See, if you observe this term and this term, both are same or not? Yes or no? Yes or no? So you can write it as 2k q square into root 3 by a square into 2 plus 3k q capital Q by a square. So this must be equal to what? This must be equal to 0. So I have added up these two here, okay? So here 2 will get cancelled. Now here what you can take common here? K Q by a square you can take common. Yes or no? So k q by a square, k q by a square you can take common. So therefore finally what is left out? Root 3q is equal to what? I am sending this to other side, so you will get minus 3q, okay? So here root 3 once, and here you will get root 3. So therefore capital Q is equal to what? Is equal to minus q by what? Minus q by root 3. You can remember this as a standard result here for square and as well as what? As well as for triangle. Okay, so if they give q value, that is placed at the vertices of a equilateral triangle, then you can directly determine what is the capital Q that has to be placed at the centroid. Understood? It is very simple or not? It is simply minus q by root 3. So you can remember this as what? This as a standard result. So for the previous case, sorry. So for the previous case, we got capital Q is equal to minus q by 4 into 2 root 2 plus 1. So you can remember directly this standard result. So if they ask the question, then you can directly answer the question here. So depending upon this small q value. Understood? Okay. So what is the charge that you have to place exactly at the center of the equilateral triangle? That is nothing but minus q by 3. That is nothing but minus q by root 3. Okay. So okay, so exactly at the centroid, you have to place minus q by root 3. So this is the charge you have to place here. Okay, so I hope you have understood this problem here, right? Is this clear here? Tell me. Yes, so Jain minus q by root 3. Very good, yeah, very good. Parameshwar, what you are asking here? Sir, what if the net force on Q is not equal to 0 or all charges are not equal? See, if all the charges are, Parameshwar, if all the charges are not equal, then also you can determine here, but mathematically it will become somewhat complicated, that's it. Okay. See, generally whatever may be the charges here, whatever may be the, let us say here Q1, here you are having Q2, here you are having Q3, here you are having, if you take different charges here, then the net force exactly at the center cannot be equal to 0. Understood? See, for all the charge combinations, it cannot stay in equilibrium. It is not possible. For all the charge configurations, it is not possible to stay that system in equilibrium. The system cannot be in equilibrium if you take some arbitrary charge configurations. It is not possible. Understood? Okay. See, if I take here some value of Q1, here I can take some other value of Q2, and here I can take some other value of Q3, then the net force at this location cannot be equal to 0 if you take some random charges. Yes or no? Understood? Okay, so in that case, whatever the, even though you can take the charge, some charge here, some arbitrary charge here, such that the force on Q1, the force on Q2, the force on Q3, let us assume you are making it equal to 0, let us assume, but the net force on Q, whatever that you are placing here, cannot be equal to what? Cannot be equal to 0 if you choose some random charges. Understood? Okay, even though the force on Q1, Q2, Q3 becomes equal to 0, the force on this charge due to all the other 3 charges cannot be equal to 0 if you choose some random charges. Understood? Okay, so that type of problems they won't ask here. That type of they don't give some random charge distribution and ask to determine the field and all. Okay, so it is not possible to any person to calculate mathematically. Understood? Okay, so don't worry about that. They will give some standard problems that is having symmetry like this. Understood? Equilateral triangle and all the point charges are of same, all the point charges are identical, so like that only they are going to give you here. So that whatever the problem they will give, it is going to maintain some symmetry, then only the problem can be easily solved. Okay, okay. So I hope it is clear here, I hope it is crystal clear. Yes, Parameshwar, is it clear? I hope your doubt is clarified, right? See, they don't pick some random question and ask you to solve here, right? Okay, so whenever they are asking some question means it is going to have some meaning, right? Okay, right. So I hope it is crystal clear here, I hope it is crystal clear. Okay, so I will give you one problem here as a homework. I will give you one problem as homework. So can you do that one here? If you need any homework problem, I will give you here. If you are not interested, I don't give. So please respond. If you want any homework problem, I will give you. Otherwise, we will wind up the session with this. So I am waiting for your reply here. If I don't get any reply means I don't give any problem. Okay, with this we can simply wind up the session. If you are ready to solve any homework problem, I will give one problem here. Otherwise, we will wind up the session. Yes, tell me, do you need any homework problem? Yes or no? Okay. So try to solve this problem here. So here you are having some rigid slab. Let us assume this is rigid slab here. This is a rigid slab. Okay, this is rigid slab. two objects having mass m is equal to 2 grams each is two objects having mass m is equal to 2 grams each and charge on each object is same, that is Q. Two objects having mass m equal to 2 grams each and charge on each object is the same, that is Q. Okay, so if these two objects are suspended from a rigid slab from a rigid slab with the help of two massless strings. So these charges repel each other and reaches an equilibrium position. Repel each other and reaches an equilibrium position. Such that the massless strings makes an angle theta equal to 45 degrees with respect to vertical as shown in figure. So this is the figure here. This is the figure they have given, right? So what is the question? Two objects having mass m equal to 2 grams each and charge on each object is same, that is Q. If these two objects are suspended from a rigid slab, this is rigid slab here, suspended from a rigid slab with the help of two massless strings. So this is the massless strings. Two massless strings of length, you can write here, of length L is equal to 0.5 meters. Of length L is equal to 0.5 meters. So then these charges repel each other and reaches an equilibrium position such that massless strings makes an angle theta equal to 45 degrees with respect to what? With respect to vertical as shown in figure. So this is one massless string, this is also another massless string. So here also this angle is also what here? This angle theta is also equal to what? Here also this theta is equal to what? 45 degrees. So what is the question they are asking is, this is rigid slab here. So from the rigid slab they have suspended two objects each of mass m and the charge on both the objects is also same. Okay, that is Q, right? Okay, so whenever they have suspended these two objects from what? From a rigid slab, since these two are having the same charge, what they are going to do? They are going to repel each other. So once they repel each other, they are going to move away from one another. So they will start moving away from one another, and finally they have reached a equilibrium position. So what do you mean by equilibrium position here? Equilibrium position means at that position the net force acting on that object, will become equal to what? Will become equal to 0, and hence that object will not move further. Understood? So that is the equilibrium position. That means in the diagram they have given the equilibrium position here. So under this equilibrium position they are saying that this massless string is making an angle theta equal to what? Theta equal to 45 degrees with respect to vertical. Then what you have to do? You have to determine the value of what? The value of charge q. You have to determine the value of charge q. Yes or no? So these charges repel each other and reaches an equilibrium position such that massless strings makes an angle theta equal to 45 degrees with respect to vertical as shown in figure. So then determine value of q. Okay, then you have to determine the value of the charge. Understood? Okay, so I will just give you one clue here. See here. So this is equilibrium position. They have given that this is what? They have reached to equilibrium position. So equilibrium position means what here? Equilibrium position means net force acting on it must be equal to what? Net force acting on it must be equal to 0. So you have to determine what are the forces. First you have to draw what are the forces that are acting on the object. See here. See what are the forces that are acting on this object here. Tell me what are the forces. See here you are having q, here you are having q. So both are having some charge q and both are of same polarity, so they are repelling each other. So that means the force on this charge q due to this q is going to point in this direction. Yes or no? So this is the electrical force. Okay, one force is due to what? Due to this charge. So the force on this charge q due to this one is going to point in this direction, that is along the line joining these two charges, that is in this direction, right? Next, if you observe this object is having mass m here. It is having mass m. So whenever an object is having mass m, then it is going to experience what? It is going to experience a gravitational field force or not? Yes or no? So any object having mass m is going to experience a gravitational field force. So the gravitational field force is going to act in which direction here? It is going to act always towards what? Towards the surface of the earth. So that means it is going to act in downward direction like this. So this is the gravitational field force, right? Next, what is the other force that is acting on this object here? See this thread here. This thread is trying to pull this object in this direction or not? Yes or no? So this thread or this string, this massless string is trying to pull the object in this direction. Yes or no? So that means this massless string is also applying a force on this object in this direction. Okay, so that force here, that force applied by the string, we call it as what here? Tension force. So always remember the tension force must be always point away from the point of contact. See here, this is the massless string, this is the object, so this is the point of contact. Between what? Between massless string and object. Understood? Okay, so this string is going to apply a force on this object in this direction. So that force applied by the string on the object, we call it as what here? Tension force. And this tension force must be always what? Must always points away from what? Away from point of contact. That means it is going to point in this direction, right? Yes or no? Okay, so now if you observe, this gravitational field force is acting in downward direction, this electrical field force is acting in horizontal direction like this. Yes or no? And this tension force is neither horizontal nor vertical. So you can resolve this tension force into two components. One is what here? One is vertical force and another one is what? Another one is horizontal direction. Yes or no? Now what is this angle here? What is this angle? So the angle between this line and this vertical is nothing but 45 degrees. So the angle between this one and this one is also what? This one is also 45 degrees. So that means this will become what here? T cos 45. This component will become T cos 45, that is in upward direction. This component will become what? t sine 45, t sine 45 in negative x direction. Yes or no? Now in horizontal direction, what are the forces acting here? So here electrical force is acting in this direction. Yes or no? And t sine 45 is acting in this direction. Understood? So you have to make this net horizontal force is equal to 0. Next, what are the vertical forces that are acting here? Vertical forces that are acting is t cos 45 is acting in upward direction. The gravitational field force is acting in downward direction. Yes or no? So if you consider the object here, so in this direction you are having electrical force, in this direction you are having gravitational field force, so here you are having the tension force. So you have to resolve this into two components. So this angle is 45 degrees, so this will become t cos 45, right? So its component, this one, will become what? Will become t sine 45, right? Now you have to equate, the magnitude of this horizontal forces and this vertical forces must be what? Must be same. Yes or no? So that means you have to equate Fe is equal to what? Fe is equal to t sine 45 and Fg is equal to what? Fg is equal to t cos 45. You can equate this one. Understood? Because this force, this vertical force is acting in upward direction. This must be equal to what? This must be equal to gravitational field force. And this t sine 45 must be equal to what? Electrical field force. So then the net force, then only the net force here will become what? Will become equal to 0. Yes or no? Why we are making net force equal to 0? Because they said that the object is in what? Equilibrium position. That means the net force acting on that object must be equal to 0. That means all the vertical forces must go to 0 and horizontal forces must also go to 0. Then the net force will become equal to 0. So this is the condition. This is the condition for horizontal force to become equal to 0, and this is the condition for vertical forces to become equal to 0. Understood? So from this here, you know Fg is equal to what? Fg is equal to m into g, and you know electrical force. This is the electrical force between what? Between these 2 point charges or not? Yes or no? So you know how to determine the force between 2 point charges that are separated by d distance. So write the expression for this one, write the expression for this one. So from this you can easily simplify and you can get the value of what? You can get the value of charge q. Understood? Okay, so I hope you can do this one here. I hope you can do this one. So I have given everything here. I have given everything. Just you have to solve this one and try to determine q value. Okay, so will you do that here? Can you do that? Yes or no? So Parameshwar, Abhijit, Parasmoon, Sujal Jain, tell me here, can you do this one here? Yes? Sorry. I have given everything here, right? I hope you can do this one, right? Yes. Parasmoon, yes. Remaining persons here, respond here. Abhijit, okay, fine. Parameshwar, Sujal Jain, okay. So I have given everything here. So try to solve this problem and try to determine the charge. Okay. So I hope you have enjoyed this session here. Okay, so we have solved some typical problems today based on what? Based on Coulomb's law. Right? Okay, so tomorrow sorry. So tomorrow we are going to start electric field here. We will start electric field, right? And we try to solve some problems based on this electric field also. Okay, some interesting problems we are going to solve. So we try to determine the field due to a circular ring. If you are having a charge is distributed around the circular ring, okay, uniformly, then what is the field? At some location due to this circular ring, and we will solve circular disk problem also. Circular ring and circular disk problems. So this type of problems we can solve here. Okay, tomorrow's session. So don't miss the tomorrow session here. It is going to be very much interesting. We'll solve some problems based on electric field, right? So if possible, we'll solve these two. So before these two, we try to solve some problems here from 3 to 4 problems. So once we complete those 3 to 4 problems, then we try to solve this one and this one. Okay, so once you get familiar with the electric field and once you get familiar with this Coulomb's law, then we'll go for what? We'll go for Gauss law here. Then we'll go for Gauss law. Okay, so I hope you have enjoyed this session here. So tomorrow we'll start with electric field. Tomorrow we'll start with electric field. So we'll meet exactly tomorrow at the same time here. At the same time, 4 p.m. Exactly at 4 p.m. we will meet. So daily EMT sessions will be conducted exactly at 4 p.m. here, exactly at 4 p.m. Okay, so please daily attend the sessions here regularly so that you will enjoy the subject and you will get rid of the fear of EMT here. It is going to be very interesting subject here. It is actually very interesting subject. Understood? So if you understand the concepts clearly, then you can easily score the marks in this subject. Actually, whatever the questions they are asking in this subject, they are not this much difficult questions here. They are going to be very, very simple. So if you prepare at this level, then you can easily answer those type of questions that they are asking in GATE. Understood? Generally, they will ask very simple questions in EMT. Okay, you can easily answer those questions within less time. Actually, it is a scoring subject here. Understood? Okay, it is a very good scoring subject because the questions are going to be very simple, but only one thing is you must have crystal clarity on the concepts. That is the only thing. Okay, so if you understand the concepts very clearly, then you can easily score the full marks in EMT. Okay, so tomorrow exactly at 4 p.m. we will meet here. We are going to start the session. So today, as far as today is concerned, I am going to wind up the session. Understood? So tomorrow exactly at 4 p.m. we will meet again. Okay, so until then, take care. Bye bye.